advantage of .11n is aggregation of frames. Which means we are now able to combine more than one frame together. Okay, it's like A-MSDU and A-MPDU. You know what MSDU is like. MSDU is the payload, data payload, right? And MPDU is the complete 802.11 frame with the headers, right? So now we can actually combine these frames together into one big frame to make sure that efficiency and speed both are increased. How this works is, let's take an example of an A-MSDU. Okay, if you are combining A-MSDUs, this is how it's going to look like. So you combine all the MSDUs coming from the top, make one MSDU chunk, and then put this whole thing inside one MAC header. And this is your A-MSDU. This is one aggregated frame of A-MSDU, right? Now this is something which is highly used in a .11n protocol, where you are combining multiple frames into a single frame transmission. That's exactly what A-MSDU is. So in this, you create the A-MSDU. Now when you put the MAC header, it kind of becomes, or I should specify this better, this entire thing becomes A-MPDU. But when we combined MSDUs together like this, MSDU1, MSDU2, MSDU3, this is an A-MSDU. When you put the MAC header and the trailer, it becomes the A-MPDU, which is the .11 frame, right? Now, there's another way by which we can aggregate frames. That is called A-MPDU. This was A-MSDU, aggregated MSDU. This is aggregated MPDUs. Now, what you do is you create multiple MPDUs. MSDU plus the header, MAC header. Then we have a different MSDU. Then we have a header here, MAC header. Then we have the third MSDU. Then we have a header here. Now all these three are three MPDUs. So this is called, or I should say, MPDU1, so that it's more clear. MPDU1, MPDU2, MPDU3. Now this can become something like this. MPDU1, MPDU2, MPDU3, and on this entire aggregated MPDU, you put a physical header, right? This is how frame is transmitted, right? When it goes to the PLCB on the physical side. So aggregating the MSDUs, you are actually aggregating data payload and then putting just one header on top of it and sending it through for transmission. MPDUs, you are actually combining multiple MPDUs together. So you have a single MPDU with one header, then again you have an MPDU with another header. So you are actually combining all the MPDUs together and sending it to the physical layer for a physical header on top of the complete frame, and then you send it out for transmission. That's A-MPDU for you, right? Now this is something which is also used in .11n, and aggregation of frames like this helps a lot in increasing the throughput of the client. This is another contributing factor in the throughput of the client. So this was, I think this was the sixth advantage of .11n. The seventh advantage is something like, I mean, anyway, before we go to the seventh, there's one more thing which I want to explain in the sixth part. The moment we say we send A-MPDUs or A-MSDUs, now if I'm a transmitter and I'm a receiver, and this is a receiver, I send back-to-back frames like A-MPDUs I send towards the receiver. The receiver will send back a block ACK. I think we spoke about block ACK in the earlier videos. This is how block ACK works. You send a block of frames. In return, instead of acknowledging every small MPD or MSDU in between, it will send one block ACK to acknowledge the entire aggregated frame. So that's how the transmission becomes faster as well. Okay, so this is the part where block ACK plays a role. The next advantage of .11n, which is power adaptation. If you remember, we talked about in spatial multiplexing that a transmitter can have up to 4 antennas. The standard supports up to 4 antennas, but the client also needs to be capable of that. So in power adaptation, when a station does not have anything to send, if it's a client, if a station has nothing to send, it will shut off 2 or 3 of its antennas and go to sleep. So now the client effectively, from 3x3 or 4x4, it kind of became 1x1 in a way, and the rest of the antennas are kind of sleeping and conserving power. Now whenever a client receives a clear to send from the AP says, okay, I've got some data for you, I've got some traffic, I send a clear to send to you, can I send traffic to you? Or I'm sorry, it receives a request to send from the AP, not a clear to send, but request to send, asking for permission to send traffic. At that moment, the client will immediately wake up, and then the AP can then blast the traffic at higher data rates to the AP. Okay, this is power adaptation. The antennas adapt to the power conservation, where they'll go off to sleep, and then they'll only have one antenna up and running, which is enough to sense that somebody wants to send me traffic. And then the moment it receives a RTS request to send from any other client or any other AP, it knows that yes, there is some data waiting for me, and then I have to basically get up and then turn on my other antennas also, and then start receiving traffic. This is how the client or the user or the AP, they adapt to power management in .11n. Okay, so now this was all about the advantages of .11n. I don't think I missed out on any, but yeah, there are, just like advantages, we also have a couple or three of disadvantages, which I will talk about in the next video. Thank you.